Welcome back to 4.3, part 2. And in part 2, we're going to do some application problems with arc length and sector area. Like I said before, the challenging part about this is we have these two formulas. And in these two formulas, we see that we are repeating two key variables, two key values. Radius is repeating, and our angle, or theta, they're repeating. And this, we're probably talking about the same angle and same radius if we're talking about the same piece. If I talk about this piece, theta is the same and my radius is the same. As a result, we want to be very versatile in using these problems. So let's actually begin with this from our review. A cheesecake is cut into 12 equal slices. One slice of cheesecake has a sector area of 4 pi over 3 inches squared. And the end result, which we'll get to without a guiding question, is I want to find the arc length. I want to go from area to my arc length. So let's see what we need. I always like to work backwards from my end result. If arc length is what I want, and this also working backwards help me keep track of the end goal. If arc length is my end goal, I must use this formula because that's the only formula that we know for now. Arc length equals theta times r. And try to figure out what we have. So let's look for theta in this case. A cheesecake is cut into 12 equal slices. 12 equal slices is a big indicator. It is a very common thing that we use, cutting something into equal slices. So if I have a whole circle of angle 2 pi, and it's being cut into 12 equal slices. That is not very nice, but we have 12 pieces. It's being cut into 12 slices. What is happening to my angle? My entire angle of 2 pi is being divided into 12. So I'm being cut pi over 6. My theta equals pi over 6. So this is a key thing, a thing we want to watch out for. If I see something that has equal slices, we should immediately think, oh, I can find theta because it's being cut into equal slices. So that's a little hint that we could have. So I know my theta equals pi over 6. Now I need to find r, my radius. So a cheesecake is cut into 12 equal slices. I got everything I could out of that. One slice of cheesecake has a sector area of 4 pi over 3 inches. Sector area. I'm given sector area. So I want to find this. This is what I want to find. This is what I have. I have theta equals pi over 6. I'm also now given my area is 4 pi over 3 inches squared. So I'm given this. I found this out. I must use this. Now I look and see, can I find radius given this information? I try to look, I see what formulas I know. I can't use this one because that's what I'm using for the end. I look over here, I have area, I have theta, I have radius. I know 2 out of 3 and 1 is unknown. You could solve for the unknown if there's only one unknown. So I'm going to rewrite this formula. My area, 4 pi over 3, equals 1/2 r squared pi over 6. Combine my sides, 4 pi over 3 equals pi over 12 r squared. Divide by pi over 12. And I'm going to write it out just in case. So 4 pi over 3 divided by pi over 12 is 4 pi over 3 times 12 over pi. Pi's cancel out. The 12 and 3 simplify into 4 and 1. I could take it 3 out of both. So 4 times 4 over 1 over 1. This is 16. 16 equals r squared. I want to square root it to get r equals -4 and +4. And my radius can't be a negative. I can't have a negative length. So I get rid of that. My radius is +4. R equals 4 inches. There's a lot going here. I'm just going to narrate through it one more time. I want to use my area formula because I know my area. I know my theta, my angle. I need my radius. You want to make sure you do something that you need to do. So I plug it in. I combine the right side into pi over 12 r squared equals 4 pi over 3. I get rid of pi over 12 by dividing. I divided it to get 16. So 16 equals r squared. I square root to get rid of the square. And when you square root, you get a positive and a negative. Because -4 squared is 16. Because negative times a negative is positive. Positive 4 squared is 16. Because positive times positive is a positive. Negative gets rejected because it's a negative length. So my radius is 4 inches. But I'm not done yet. I still want to look up. I see arc length. I underlined. I put a star next to this. I need arc length. So I go down here. S equals theta r. S equals pi over 6 times 4, which gives me 2 pi over 3 inches. And this is my arc length. A lot happened at once. But this is the next step from just plugging in this formula. You want to build up word problem skills just by doing more and more word problems and different word problems. So we see we want sector area, we want arc length, we're given some values. I can find it. And like there's little tricks, as in this 12 equal slices gives me theta. Let's do one more. So a section, we have a 6 centimeter, a section of the circumference of a 6 centimeter circle has a length of 3 pi. 3 pi. What is the area of a sector with the same angle? I have a circle. The section of a circle. The section of a circumference. This actually is worded weird. But a section of circumference is the arc length. Because the circumference is the whole arc. And then a section of it as a piece of the arc. And an arc length of a 6 centimeter circle, whenever you see a measurement given to a circle, that is the radius. So the arc length of a 6 centimeter circle has a length of 3 pi. So my radius is 6 centimeters. And a section of it, I'll just mark this, is 3 pi. What is the area of a sector with the same angle? And this kind of gives us a little hint. We want to use the same angle. We want to find theta first. But the end goal is area. Area is my end goal. I need this. So since area is my end goal, I'm going to write my formula out and fill in as I go. I need to find radius. I need to find theta. We do have radius already. Radius is 6 centimeters. And theta is unknown. So I look back at my formulas and see what formula do I know that uses theta. And I see S equals theta R. And that's also better as well because I do have R already. So I'm going to use R. Theta is right here. And let's see, do we have S? The arc length of a 6 centimeter circle has a length of 3 pi. I see, I do have S. 3 pi equals theta times 6, divide by 6, divide by 6, to get pi over 2 equals theta. Now out of theta, I'm going to plug it back in, plug R in. Area equals 1/2 6 squared times pi over 2. 1/2 36 pi over 2. 36 pi over 4, which gives me 9 pi centimeters squared. So here are just 2 example problems. And if you ever want more, if you ever need more, this concept, circular geometry, that is kind of vague. If you ever want more, what I recommend looking up if you want to find more practice problems is our concepts are arc length and sector area. So you can look up those problems. You can be like arc length and sector area, practice, PDF. And that is kind of what I do when I study for math problems. If I know the concept, like this is my concept. And I just write practice and PDF. PDF is like the file type, like a printable file. And practice, you can replace practice with homework. You can replace practice with like exam or test or like Quizlet. You like replace this all for like Quizlets and stuff. But yeah, just find problems. Also look to see if they're answer key, because if you do a practice without really knowing if you're right or wrong, it's not as beneficial. Yeah, good luck studying.